So I got a request to go through question 35 as well. It's asking which statements are correct. Unfortunately, this is just all about learning your reactions for your halogens in group 17, group 7. I'm going to start with the easiest here. This third one here, an acidic solution forms when chlorine is added to water. Now, most of us should know this. This is a reaction that is used to sterilize, basically. So a small amount of chlorine added to water will sterilize it. So we've got Cl2 plus H2O, and we're going to produce HCl, which you know is a common lab acid, and HOCl. Okay, you might see this written HClO as well, depending on which textbook you're looking at. Okay, so this is an equation you need to know, you need to learn. I will just mention a couple of things here. If we look at the two chlorines here, okay, and you work out the oxidation numbers, you're going to find that they have two different oxidation numbers. So I'll let you do that. But this is actually an example of a disproportionation reaction. Okay, this is here. The question doesn't ask you to know that, but I think that's good to know, because it tells us what a disproportionation reaction is. Well, it's one in which one species will both be oxidized and reduced. I repeat, disproportionation is when one species going into the reaction will be oxidized and reduced. In this case, we're talking about the chlorine. Okay, so we can safely say that point number 3 there is correct. Let's look at point number 2 now. Okay, so I've copied in the equation here for the reaction of chlorine with cold NaOH. Here it is. Now, we've got the oxidation numbers labeled here, and the key point is that if you look at the oxidation number of chlorine here, it's a 0 going in its elemental form, and it's coming out in two different oxidation states, okay, as -1 and as +1. So this is a classic example, and really one of only 2 examples that you're going to need to know about in the whole AS course, which is a disproportionation reaction. Okay, so this is also correct. So far we've got 2 and 3 correct. So now let's move on to look at number 1. Okay, so for number 1, again, it's all about knowing your equations for the reactions of group 17 compounds. So we've got sodium chloride reacting with sulfuric acid, concentrated sulfuric acid. In this case, our products are here. Now it's asking, the chloride ions are oxidized. Well, are they oxidized in this reaction? No, they are not. Why? Because we've got exactly the same oxidation state for the chloride ions going in and for the chloride ions going out. So there's no oxidation going on here, okay? Just the important theory to know is that the sulfuric acid is indeed an oxidizing agent, okay? But it's not a strong enough oxidizing agent to oxidize the hydrogen chloride poisonous gas produced, okay? However, important to know, because this might happen for future questions, if this was, for example, sodium bromide, or if this was sodium iodide, then the sulfuric acid would indeed be strong enough to oxidize them, and you'd end up with your atomic versions of the halogens being produced. So you'd have bromine being produced for sodium bromide and iodine being produced for sodium iodide. So that's very important to know. But for the purposes of this question, that was incorrect because there's no change in the oxidation state there. There's no escaping it. You need to know that equation. Part 2, this was correct as we've discussed, and part 3, this was correct as we discussed. So what is the actual answer here? It's C. 2 and 3 only are correct. Okay, hope that has helped. Bye.